Hi and welcome to a new episode of How to Peplink. My name is Joey, Senior Technical Engineer from TBV. Today we will explain the difference between the 5G-D, 5G-H and the new 5G-N modems. Just like the original BR1 Classic, the BR1 Pro 5G has certifications to meet the standards of a wide array of deployment scenarios. The MAX BR1 Pro 5G industrial router is designed for heavy-duty industrial and mobile applications. It has a compact rugged enclosure. You will find the BR1 Pro 5G in many different deployments like a race car, public transport Wi-Fi, payment terminals in stores, and alarm system. So what is the difference now and why are we making this video of a well-known product? Let me explain. What is currently used? If you currently have a 5G capable device on Peplink, you might notice that the SKU ends with either 5G-D or 5G-H. The key difference between those two models is that the 5G-H has US carrier certification, meaning it's primarily used in the North American market, whereas the 5G-D is not certified for the US market and is more used in the EMEA or APAC markets. The 5G-D and the 5G-H have the same chipset, built on the X55 platform made by Qualcomm. This platform was the first generation 5G platform used widely in any router application. Both 5G-D and 5G-H models allow carrier aggregation on low band or mid-band frequencies, but not both frequency spectrums at once. This could result in lower performance in low signal areas on either spectrum. What is new? So all this explains about the current modem types. So what is new? Let me tell you. Peplink is slowly introducing the new 5G-N modem. This is an improved second generation 5G modem. The new generation supports global deployment and even more bands. This modem is US carrier certified. AT&T, T-Mobile, Verizon. The C-band and FirstNet are included. There is no need for an additional modem if you are traveling from Europe to the US. The new 5G-N modem is based on the Qualcomm X62 platform, and this allows the 5G-N modem to be more powerful than the first generation 5G modems that are based on the X55 platform. And thus, being able to do carrier aggregation with a low and mid-band frequency, this means enhanced speed, range and reliability. Carrier aggregation works with 2 or more frequencies at the same time over different antenna connectors on your modem. With the current 5G modems, you could connect with 4 frequencies at a time. Of course, this needs to be provided by an ISP and relies on the number of bands available in your region. That's why the more bands you have available, the more you can utilize the maximum number of bands within the carrier aggregation. On screen, you'll see a quick overview of bands available per modem. As you can see, B43 and B48 supported by the 5G-H and the 5G-N modems. These bands are specifically for private LTE networks. When talking about 5G bands, we talk in N bands. In the same overview, you can see that the 5G-N has more bands compared to the other 2 modems. Peplink plans to implement this 5G technology with their current 5G lineup and release a new series of 5G-N models. How does this work for your deployment? The 5G-N modem supports both standalone and non-standalone by default. Let me first explain what are standalone and non-standalone networks. Non-standalone uses the 5G frequencies, most known as the N bands, for example N28, the 700 MHz frequency, and based on the 4G core or hardware in the cell towers. The standalone networks also use the N bands, like N77, which is the 3.5 GHz frequency. This is an end-to-end 5G network, or in Peplink world, a BR1 Pro 5G connected to a cell tower with a 5G core or hardware, otherwise known as a true 5G experience. Previously in the 5G-D and 5G-H modems, there was no standalone option by default available. Did you know that as of July 2023, there were only 47 mobile network operators that have enrolled their 5G standalone network. We are expecting this will rapidly expand in 2024, as many mobile network operators are testing the standalone networks on small and large-scale projects. And this means that the 5G modems are more suitable for the standalone networks and private LTE 5G networks. Also, deployments where low latency is key, like self-driving cars or live sport events, the standalone has lower latency than the previous generation networks. To wrap it all up, the BR1 Pro 5G will be having a modem upgrade to a better, more reliable modem without changes to the other router hardware. The 5G modem will be able to support simultaneous carrier aggregation between low and mid-band frequencies, and will utilize the full 4-antenna connector setup. With previous modems, there were options to work in a 2-antenna connector setup. With the special 2x2 antenna mode introduced in firmware 8.3.0, the 5G modem does require all 4 antenna connectors connected.